This video is about chemical bonding. Quite often in GCSE teaching of chemistry, the subject is taught in a linear fashion. You learn about one thing after another, and sometimes the bigger picture is not clearly presented. Here I'm going to link the types of bonds to the periodic table and also to electrolysis by talking about ionic equations. These things are all related, and if you look at it that way, it should help you. Let's look at the periodic table to start off with then. 100 or so elements, most of them metals. I'm going to suggest that first of all you learn the non-metals. Now the elements on the boundary of metals and non-metals are often called metalloids, and you won't get those come up in the exam question. So we can ignore them for the moment. If we go to the far right and we look at group 8 or group 0, all those elements apart from helium end in ON, so they're recognisable. That leaves about 10 more non-metals. You should also be learning about group 7 separately. Their names end in INE, and you should know what each of those looks like. For example, fluorine being a pale yellow gas. Again, that will come up separately in chemistry. So if we take all those out, there's only 6 non-metals to learn. Carbon, nitrogen, oxygen, phosphorus, sulfur and selenium. You'll have heard of most of those anyway. So these 6 with hydrogen, group 7 and group 8, are the non-metals. And remember, you will have a copy of the periodic table in your exam. Okay, the second thing to be certain about before we progress is the structure of an atom. Positively charged protons and neutral neutrons are present in the nucleus. The electrons, negatively charged and of much less mass, are in shells around the nucleus. Only the outer shell electrons are involved in chemistry. In fact, the outer shell electrons and the energy that they have is what chemistry is all about. An important point here is that the number of electrons in the outer shell of an atom is indicated by the group the atom is in the periodic table. Take a minute or two just to appreciate how much help that is to you. Pick an element. Aluminium, for example, is in group 3. That means it has 3 electrons in its outer shell. And remember, the periodic table is there for you. Unfortunately, the modern periodic table often has a different group numbering system, and that's not as helpful. In a chemical reaction, the number of electrons in the outer shell can change. Now, in an atom, the number of electrons must equal the number of protons, so that the total charge is 0. An atom that loses or gains electrons becomes an ion and it has a charge. This atom has lost 2 electrons, so it will have 2 more positively charged particles than it has negatively charged ones. So it has a net charge of +2. This atom, on the other hand, has gained 2 electrons, so it will have 2 more negatively charged particles than it has positively charged ones. So it has a net charge of -2. Atoms lose or gain electrons to achieve a full or empty outer shell. Now, we're ready to talk about bonding. Metal atoms lose outer electrons to join with other atoms. Non-metal atoms gain outer electrons to join with other atoms. In the first type of bonding, non-metals join to form molecules, and this is called covalent bonding. The atoms share electrons, so they gain electrons from each other. In the second type of bonding, metal atoms lose electrons to form a lattice. They lose electrons to the space around and between them. When many atoms do this, we say there is a sea of free electrons or a sea of delocalized electrons. Because this only happens with metal atoms, we call it metallic bonding. And we represent this using a picture like this one. And so we come to the third type of bonding. Metal atoms can join with non-metal atoms. What you get is somewhere in between the last two. So they form a lattice, which becomes a crystal. The same rules apply as above. Metal atoms lose electrons and the non-metal atoms gain them. Because both atoms form ions, we call it ionic bonding. The first type of question about this would be, what type of bonding do you get when these atoms join? So two metal atoms would be metallic, two non-metals would be covalent, and a metal with a non-metal would be ionic. The second type of question could be about how many electrons are gained or lost. Use either information about the charge or which group number they're in the periodic table to help you. Here, sodium, Na, loses an electron, so it will end up with a net positive charge. Mg, magnesium, loses 2 electrons, so it will be 2 plus in the charge of the ion, and chlorine here gains a negative electron, so it will be an ion with 1 negative charge. The final part of this video is about electrolysis. Electrolysis uses electrical energy to undo ionic bonding. 2 electrodes are used. Electrons can be lost to the positive anode, and electrons can be gained via the negative cathode. A negatively charged ion, also called an anion, can give up any spare electrons and return to being a neutral atom. A positively charged ion, called a cation, can collect new outer shell electrons to replace the ones it gave away and become a complete atom again. The electron equations, the ionic equations, are the same as before, but in reverse, as shown here. For the process of electrolysis to work, the ions have to be able to move to and touch the electrode. Therefore, the substances it works on are either dissolved or melted substances. It will not work for solids. So, to recap, make sure you know your metals and non-metals. Non-metals together make up simple molecules by covalent bonding. Metals combine together by metallic bonding to form a metal lattice. And finally, ionic compounds can be separated back to the original atoms by electrolysis. Okay, I suggest you go back through the video and make notes. Do that a few times, then test yourself. Can you compare ionic bonding with metallic bonding? Can you compare metallic with covalent? Can you compare ionic bonding with electrolysis and show some ionic equations for both of those? Good luck.